And now it is time to see that how we can perform the paired t-test on Microsoft Excel. So for that purpose, first of all, you have to put your observations in an Excel sheet, and I have taken the example of the mass of birds measured in August and September. So I have these 10 pairs of observations in the Excel sheet. Now, what is the next step? We have to press the data analysis function button here, tab here, and we will have a pop-up window, and this window has got the list of all the statistical tests that can be performed under this function. So we scroll down to see the types of t-tests that we have. We have the t-test for the paired 2 samples for means, and the t-test for 2 samples assuming equal variances, and t-test for 2 samples assuming unequal variances. So what is our required t-test in this case? So our required t-test in this case is the t-test for the paired 2 sample for means. So now, after we have selected our test, we are going to press the OK button, and then we will have another window appearing, and this window has got the boxes for the input of values. So in the first box, we are going to place our cursor, and then we are going to select the range of the first set of observations. And then we are going to place the cursor in the second box, and we are going to select the observations from the second group. So we have our observations input into the box. Now it is time to press the output range button. So the output range button is used to select the cell sheet or the workbook for the output. So if we want to have our results into the same sheet, then we have to place the cursor here, and if we want to have the output appearing into a new sheet, then we have to select this button. And if we want to have our results into a new workbook, then we have to press this button, right? Now we want to have results into the same sheet, so we are going to place the cursor here, and we are going to select the cell in which we want to have the output. After we are done with this selection, we are going to press the OK button to get the output. So here is the output. Now we expand the output and see what we have got. So we have got the mean values, which is 11.47 for the first group and 12.35 for the second group. Then we have variances, which is 0.6534 for the first group and 0.3961 for the second group. Then we have the number of observations, because these are the matched or the paired samples, so therefore it has to be same in both of the groups. And then we have the Pearson correlation value, which is 0.0841 in this case. So this is the bivariate Pearson correlation coefficient for each pair of observations. So the correlation coefficient is another test. It is another statistical analysis that is used to see the correlation between the two sets of values. So in this case, this output is giving us the paired bivariate Pearson correlation coefficient values. So right now we are not interested into this result. Otherwise, this is used just to confirm that if you have got the significant result, then whether that result is significant at the level of each pair of observations as well or no. Right, and the next one is the hypothesized mean difference. So because we assumed null hypothesis and we tested against the null hypothesis, so our assumed or our hypothesized mean difference is none. It is 0. And our degree of freedom is 9, which is the number of pairs 10 minus 1. And then we have the test statistic, which is 2.612. And this is the probability for the one-tailed test, which is 0.014. So this is significant. If we assume the one-tailed test, then it is significant. And then we have the critical value for the one-tailed test, which is the table value. And then we have the probability for the two-tailed test. So we can see that this is also significant at the two-tailed hypothesis. So this is 0.0282. And then we have the critical value or the table value taken from the t-distribution table at probability 0.05 and degree of freedom 9, and this value is 2.262. So it means that our calculated value is greater than the table value, so we are going to reject the null hypothesis, and we are going to say that there is a significant difference in the mean values of the two groups or the two sets of observations. Now we can see that these are the same results as we had calculated. So we calculated 2.612, and here also we have the value 2.612. The degree of freedom is 9 in both of the cases. The table value is documented as 2.262. Obviously this is taken from the t-distribution table, so this has to be same. And our result is also same, and that the result is significant. So this is how we can execute the paired t-test or the t-test for the matched observations of the repeated measures t-test on Microsoft Excel. So this is it for today.